we're going to use the ideas of the different trigonometric identities to help us out in this calculation. There's actually two parts to this problem, and I only have the first part written down right now. They tell us that sine of theta is negative 20 over 29, and they tell us that theta terminates in quadrant 3. The first part is to identify the values of x, y, and r. And then after that, if we need to do a second part, which is often write down the values of all 6 trigonometric functions, we have enough information to be able to do it. Like in the previous example where when we knew x and y, we calculated r, and then we could find all 6 trigonometric functions. But here we're given something different. Instead of being given the ordered pair, we're just given one of the ratios, and we're told that sine of theta is negative 20 over 29. So before we can find all the other trigonometric function values, if that's what we want, we have to know what the values of x, y, and r happen to be. So we go through this sort of logical analysis to understand it. The first thing we notice is that sine of theta is negative 20 over 29. We know that sine of theta is y over r. And we also know that r is always a positive number. It's never 0, it's never negative. So we know that this negative sign has to apply to the 20 and not to the 29. And that tells us right away that y is equal to negative 20 and r is equal to positive 29. That's the first step. We've got 2 of the 3 values that they've set us out to find. We can actually use the information of theta terminating in quadrant 3 to help confirm that we made the right decision for where the negative sign goes. So here is our coordinate plane. We know this is quadrant 3 down here. If y is negative 20 and our angle terminates in quadrant 3, we know that the point has to be in quadrant 3 someplace. And so we know that this distance is 29, and we know this vertical distance is 20 in the negative direction. So that confirms our angle is terminating in quadrant 3, and that puts our y value to be negative. What this diagram also does is remind us that the x value that this point has also has to be negative. Because remember that there are actually 2 places where the point x comma y, where y is negative 20, there are 2 locations where it could be. It could be in quadrant 3 and it could be in quadrant 4. But they're telling us that the angle terminates in quadrant 3. So we know that the point has to be here. And what that does is it tells us that the x coordinate for this point also has to be negative. If the point or the angle had terminated in quadrant 4, that would tell us that x is positive. So now we know that x is negative. So let's write it this way. Theta is in quadrant 3, and that tells us that x has to be a negative number, like y is a negative number. And so now we go to the Pythagorean theorem to help us figure out what x is. So we know that x squared plus negative 20 squared is equal to 29 squared. X squared plus y squared is equal to r squared. And we're trying to solve for x, so we say x squared is equal to 841 minus 400 squaring both of these numbers and moving the 20 squared over to the other side. So x squared is equal to 441, which means that x is equal to the square root of 441, but we want to think plus or minus here because we know it can be either one, which makes x plus or minus 21, but we know x has to be negative, so that tells us that x is equal to negative 21. So we have accomplished the first part of the problem. They're telling us to identify the values x, y, and r. We found y and r just from the ratio they gave us in sine. We use the fact that theta terminates in quadrant 3 to verify that we got the correct sign, S-I-G-N, for y, and also to remind us that x also has to be negative. So we applied the Pythagorean theorem to what we had, and we found x, the two values that were possible from the square root, and knowing that theta terminates in quadrant 3, that x has to be negative 21. So I reset my board. I wrote down the values that we calculated, negative 21 for x, negative 20 for y, 29 for r. And now that we have those three values, we can go through and use them to find the values of the other 5 trigonometric functions. So we've seen how to do that. I'm not going to do that here. But there's something else that we can do with this information, and it's something that's really important for you to recognize. Now that we have x and y, we can plot its ordered pair, negative 21, negative 20, and that would plot right here in quadrant 3. And we know that this distance is 29 because we figured it out, and we know that this angle here is our theta. And remember, we're not calculating what theta is yet. We have more to learn before we do that. In a different chapter, we'll do that. But we have this information about x and y. We have that information that they told us about, say, sine of theta, which they said was negative 20 over 29. What's important to recognize is that this is just one of an infinite number of points that would still get us this ratio. That's the interesting thing about these trig functions. They're based on what the angle is, but if we extend this line out forever, then what we have to recognize is that any point on this line, when we set up the ratio of its coordinates, whatever point we pick, we will end up with the same value as this fraction for sine. And then, of course, using the same values, we will get the same for any other of the trig functions. So for example, if I didn't pick the point negative 2120, let's say I picked the point instead, negative 42, negative 40. When I set up the ratio for sine using those two coordinates, I end up getting, first I can calculate r, which would end up being 58. I end up getting for sine negative 40 over 58, and that is exactly the same fraction as negative 20 over 29. And it doesn't have to be an exact integer multiple of these values. I picked 42 and 40 because it's just 2 times 21 and 2 times 40. But if I pick something like negative 14.7 comma negative 14, I still get that ratio of sine to be negative 14 over 20.3 when I calculated my r. and I still get the same value that I get if I put in -20/29. So get out your calculator right now and check these different values. Double check that this R comes out to be 20.3, and I will let you find the exact value of it. But the fact is you can pick any point along this ray that starts at the origin and goes off forever, forming this angle. This ray terminated in quadrant 3, and every single point on the ray will have the same ratio for sine of the angle, the same ratio for the cosines of the angles. Those will all be the same. That's an important thing to recognize. And some of the homework problems have you find different points on that terminal side. You need to recognize any points, as long as they fall on that terminal side, will give you the same ratios.